Hi everyone, welcome back. Today I'll be sharing a personal reflection on one of the most powerful forces driving modern technology, the GPU. From the early days of gaming graphics to powering AI, digital twins, and even the metaverse, GPUs have transformed how we compute, how we learn, and soon how we live. This is not just a technical discussion. This is a look into our future as engineers, innovators, and leaders. Many people today see GPUs as high-tech AI engines, but the story started very simply. GPUs were created to make video games look better. That's it. They handled textures, lighting, 3D models, and animations. But engineers eventually realized something powerful. Those same tasks depended on parallel processing, and parallel processing wasn't just for graphics. It was the key to solving some of the world's most complex computational problems. So, what began as a gaming accessory evolved into the engine of the AI revolution. The breakthrough happened when companies, especially NVIDIA, unlocked GPA programmability. Instead of just making graphics, GPUs could now do general purpose computation. This shift changed everything. uh, Scientific simulation, weather prediction, medical imaging, cryptocurrency, machine learning, and robotics, all of this suddenly had a new incredibly powerful tool. For the first time in history, massive parallel computing was available to everyday developers, not just supercomputer labs. This was the moment the world unknowingly stepped into the future. Fast forward to today, GPUs are the heart of AI. Whether it's training large language models, running computer vision, or powering self-driving algorithms, GPUs are behind the scenes doing the heavy lifting. We often celebrate AI breakthroughs, ChatGPT, Tesla Autopilot, hum- humanoid robots, but really do people acknowledge the unsung hero enabling it all? If CPUs are the brain of a computer, GPUs have become the engine of intelligence. What used to take weeks of training AI models can now be done in days or even hours because of modern GPUs. Where are GPUs going? But this is only the beginning. GPUs today are evolving into something even more specialized. Tensor cores for deep learning, ray tracing cores for real-time rendering, AI accelerators integrated directly into chips. Multi-GPU supercomputers interconnected through ultra-fast networks. We're heading toward GPUs with trillions of operations per second, enabling AI systems far more advanced than anything we've seen today. The next generation of GPUs won't just accelerate graphics, they accelerate intelligence, creativity, simulation, and decision making. Digital twins, the virtual worlds that mirror reality. One of the most exciting development is the rise of digital twins, virtual replicas of real world environments. Think about it. Enter factories simulated before being built. Whole cities tested for traffic patterns. Robots trained in virtual worlds before touching real hardware. Climate simulation run to predict environmental impact. The only reason digital twins are possible is GPU acceleration. Real-time physics, rendering, and complex AI behavior required massive graphical and computational power. We're entering a world where we can simulate reality before we ever build it. The metaverse, not just a game. Many people laugh at the word metaverse, thinking it's just entertainment, but in reality, it could be the next platform for work, social life, education, engineering, and collaboration. Imagine designing cars, building, or entire cities inside a virtual world, and every change updates in real time through GPU accelerated simulation. Imagine attending a global engineering meeting inside a virtual environmental that feels real. Imagine AI driven worlds where digital humans learn, interact, and evolve. The metaverse is not just a fantasy. It's an extension of the physical world enabled by GPU driven computation. Autono- Autonomous everything: cars, robots, machines. Autonomous vehicles are another field completely reliant on GPUs. Every second, a self-driving car must analyze camera input, detect objects, understand lane lines, predict movement, make decisions. This requires hundreds of trillions of operations per second, happening instantly. Robots in factories, delivery drones, humanoid assistants, all of them need real-time GPU computation to interact safely with the physical world. Without powerful GPUs, autonomy wouldn't just be slower, it would be possible. As future engineers, what is our role? This is where my personal reflections comes in. As future engineers, we're not just observers of this transformation. We will be the ones shaping it. We will design the algorithms, build the simulations, optimize the hardware, and create the interfaces between human and intelligent machines. The decisions we make, ethically, environmentally, and socially, will determine how AI impacts humanity. We need to think about the environmental cost of GPU's farms, the ethics of AI behavior, the accessibility of advanced technology, the safety of autonomous systems, the balance between virtual and real time. This this is more than innovation. This is stewardship of the future. GPUs started as simple graphic chips. Now they are the engines powering AI, the metaverse, digital twins, robotics, and the next era of human advancement. The future is not coming, it's already here. And we, as future engineers, and leaders have the privilege and responsibility to shape the next phase of human evolution. Thank you for listening. If you found this reflection meaningful, feel free to like, share, and comment your thoughts. Together, let's build the future we want to live in. So, that's all for today. I hope you gain something new about my reflection video.